In this video, we learn more about how to make vectors and matrices in Octave and also MATLAB. If you just look here, I just opened up Octave, and if you just plot out commands, I'm going to make an array x. X equals 1 colon 10. That means go from 1 to 10 and stepping by 1. Stepping by 1 is the default. This looks a little like t from the last one, right? It goes from 0 to pi over 2, and you give it an increment. Here, without anything in between the semicolons, with just one semicolon, without anything between the colons, just one colon, it's going to increment by 1. You can put whatever you want in there, and so you can. I'm going to say on the next line, I'm going to say, and so by the way, that was a 1 by 10, right? So x became a 1 by 10 array. All right, so now if I say x equals 1 colon 2 colon 10, that means start at 1, increment by 2, and end up at 10. Well, it goes 1, 3, 5, 7, 9. It doesn't end up at 10. It ends up, once it gets to 10, it just stops. And so it's only a 1 by 5 array now, and so but you can define what the increment is by putting it in between those two colons. So that's how to make a simple linear 1 by n array, right? How do you make a matrix? Well, let's make the matrix A here. I'm going to show you. It's square brackets on the outside, and then 1 colon 3. That's going to be 1, 2, 3. Then semicolon. That means go to a new line, and then 4 colon 6. That's 4, 5, 6. So it's going to be 1, 2, 3 on the top row, and then 4, 5, 6 on the bottom row. That's what's going to happen. And when you see when I press enter, you see that the command comes up. A is equal to 1, 2, 3 in the first row, and then 4, 5, 6 in the second row. Good? All right, so what if I wanted to make it the other way around? I could just do the transpose of that, or you can also transpose each of those vectors inside the thing. So you can say 1 colon 3 prime space 4 colon 6. Oh, those are in parentheses. So in parentheses, 1 colon 3 prime, 4 colon 6 prime. And then you can see there are two columns there. 1, 2, 3 is the first column, and 4, 5, 6 is the second column. This is a lot like how we made Z in the very first video, if you recall that. Right? So to go from one column to the next column, you use a space. To go from one row to the next row, you use a semicolon. That's how you can build up a matrix. So there's one little detail about this, is it's got to be symmetric. You can't make asymmetric matrices. So if I go A equals 1 colon 3 semicolon 4 colon 7, right? That's 4 elements in the denominator, and in the second row, it'll give me an error. It'll say, oh, I don't know how to do that, right? So it can't do that. So you have to have an n by m matrix. You can't have missing values and things like that. There are ways to do that later, but I mean, for now, you can't do that. There's tricks there. You have to use tricks in order to be able to put missing values in matrices. You can also just manually enter in numbers. So here I just say 1, 5, 8, 9 semicolon 2, 3, 5, 6, right? And so I just entered a 2 by 4 matrix there manually, each number at a time. You don't have to use colon in in the numerator, in the first row or the second row, that kind of thing. That's pretty cool, and we're going to do a lot of linear algebra type problems. The simplest linear algebra problem you can do in Octave is to do n equations, n unknowns. So in the handout, in my MATLAB handout, you can see the example of 2 equations, 2 unknowns. And here's the little clip of that. So you have these 2 equations. X plus 2y equals 5. 5x minus y equals 3, right? So it's easy to solve that 2 equations, 2 unknowns, just by using substitution. You solve for y. I'd use a second equation. I'd solve for y in terms of x and a constant. Then I'd go up, then I'd substitute that back into the first equation to get an equation only in x, solve for x, use that value of x to find out what the y value is. That's how I would do it if I were in high school in the 80s, right? Most people have calculators to do it now, so they would just enter the 2 equations, 2 unknowns in their calculator and get the result that way. That's fine. Octave can do this as well. In fact, in my opinion, it's so easy to do in Octave and MATLAB that I never use a calculator again. I mean, students have to use a calculator because there's tests and they can't open up their laptop for a test, and so they have to be able to do this. But in the real world, when you have a laptop and Octave, you just don't need a calculator anymore, really, right? Because it's such a powerful calculator. And so I'm going to show you how to do that now. So I'm going to set up the equations. If you look at the equations in matrix form, if you write the equations in linear algebra form, you have a matrix A, which is A11, A12. That's the coefficients of the first equation on the left-hand side of the equal sign, and then A21 and A22 are the coefficients on the left on the second equation, and then you have a vector x, x1 and x2, which is really, in the first example, it's just x and y. So there's two unknowns, and you can call those two unknowns x1 and x2 in this linear algebra way. And then b is just the right-hand side of the equation. So a is 1, 2, 5 minus 1, right? And you make the matrix that way by saying 1, 2, semicolon, 5 minus 1, close square brackets. And then B is just 5 and 3, 5 above 3, so it's just B equals open square brackets 5, semicolon 3, close brackets, so it's vertical, it looks right. You got to get the shape right in this, and when you're doing n equations and unknowns in Octave, but it's easy to do, right? Just use this format. Then, to find out the value of x, to solve for it, you just use x equals a backslash b. So the slash that goes the other way, not division, but the other way. This term, that symbol backslash is used for lots of things, and it's used for this. MATLAB has built-in solvers for n equations and unknowns, like single value decomposition and all those ways. I mean, I suppose you could have solved 2 equations, 2 unknowns using SVD, but man, that's like overkill, right? So, but MATLAB has an algorithm for solving n equations and unknowns that's built into that overloaded term backslash, and it shows up with the right answer. That's pretty cool, right? This works for 3 equations, 3 unknowns, 10 equations, 10 unknowns, lots of equations, lots of unknowns. Sometimes there are limits, but man, it can do a lot of equations, a lot of unknowns just with that backslash. So all you have to do is just set up the matrix A right and the vector B right, and you can do solving of a bunch of equations just like that in one line of code. That's pretty powerful. And so that also illustrates the power of MATLAB. It's not just vectorization that's good, but all the matrix manipulation and matrix processing that's built into it makes it a very, very powerful tool.